3, 2, 1, action.
Totally unnecessary, but thank you, Nathan.
Nora, what are you doing?
So as you can see, people there watching at home, that we are going to record today's lesson because several of you are either AP testing or having a field day in Texas, Alyssa Hidalgo, randomly.
Or sitting in the
So,
hallway.
anyway, or sitting in the hallway. So, 8-1 and 8-2. Yeah, that awkward noise that you're hearing is Stevie and Justin having a conversation. These are the things that are going to make this video really long. Okay? But anywho, 8-1 and 8-2, we're talking about a specific type of function. Do you guys remember what they're called? You just did the homework on it.
Exponential.
Exponential functions. Okay, and so you can see the title for today is logarithmic functions as inverses. Logarithms are the inverse function of an exponential. And we also talked about inverses already, right?
Yeah.
Remember that? You have a function. If you put the inverse into the function, then what do you get back?
The inverse.
Okay. I'm not even going to ask any more questions. Let's just do something really easy. Let's say you have y equals 2x plus 3. The inverse function would be x minus 3 divided by 2, because I can do that in my head. And it's okay if you can't, but this is the inverse function. What I'm saying is that when you put this function inside of that function, in other words, if I were to take the input, which is the x, and instead of putting an x in there, I'm going to input the entire original function. And I put 2x plus 3 there. This is composition. Remember f of g of x? Remember that? It's all coming together now. So I put this function inside, and what happens? Plus 3 minus 3, you just get 2x divided by 2. So what you get back is x, Nara. You get x back, okay? You can also go the other direction. You could say 2x plus 3, and you could put the inverse function into the original function. Either way you go. And so in this case, you would have x minus 3 divided by 2. The 2's would cancel, and you have x minus 3 plus 3, and then again you'd have x back. Either direction that you go, you will get the x back. That is the idea with inverses. Now you have to remember that. Even though you're not going to always see the function, this is easier, and the reason why I chose a linear function is because you can very easily, concretely see what the function is doing. You can see that it's timesing it by 2 and adding 3. You can see that it's subtracting 3 and dividing by 2. You can concretely see that. But you don't necessarily see that when you have trig functions or exponential functions or logarithmic functions. It doesn't look the same, and so you tend to get like, what? What's going on? But I want to remind you that this concept of inverses applies to any function. Whenever you put an inverse function with a regular function, it always gives you back x, because x is the identity function. I know that we did this last year, and I want to show you just one more example of how you've used this in the past, and that was with sine and cosine. We did that in geometry at the very end of the year. We're doing it now with the current geometry class. And it was like sine x equals, I don't know, 102. And I would ask the class, and I've asked them again, how do I get rid of sine? This is a function, sine of x. How do you get rid of sine? And everybody always wants to divide. And it's so wrong. You cannot divide by sin, okay? Sin is like nothing, and it doesn't work that way. That's like saying f of x equals 102, and I'm trying to find x, and you tell me to divide by f. Is that f times x? No. So dividing by f is like the stupidest thing on the earth, right?
Yeah.
So this is not times. This is sine of x. Sine is the name of the function. So you can't divide by sine. This is not how it works. What you can do is take the inverse of the sine on both sides. Notice the inverse notation. Okay? And that's how we learn to do that in geometry. Okay? The inverse of it. Again, we can't see what the sine function is doing like we can with the 2x plus 3, okay? We can't see what it's doing. But if we understand how inverses work, we understand that when I put the regular function inside of the inverse function, what's supposed to happen? They're supposed to cancel, giving you back x. Do you see what I'm saying? So, I say all that, and lucky for you, we're not going to do trig right now, but if you're going to do pre-cal next year, we're going to do a lot of trig, and you'll see this again. We're talking about logarithms. So first, I want to begin, so to speak, with well, not yellow, that's for sure. I want to begin with a darker color.
I like yellow.
Oh my goodness, the gods do not like me today.
I like you.
Wow. OMG.
It's like noodles.
I look like half like it.
Ah, thank you.
I'll do panda. Noodles.
Lame thing. Okay, y equals b to the x, I guess. This is a very basic exponential function. The exponent is is a variable, unlike a quadratic or a polynomial where the base, this is a polynomial, right? The base is the variable and the exponent is a number, but they kind of switch roles. Things like y equals 2 to the x power. The base is now a normal number and the exponent is a variable. That's an exponential function. You graphed them in the previous lessons, right? You were graphing exponential functions. So now we want to find the inverse of the exponential, and that is a log. And like the sign, it's going to be new to you, so at first you're going to be hesitant, but I promise you once you get your mind around it, it's not that bad, okay? So we're going to have log base b y, log base b of y equals x. This is like the different notations, okay? So I'm just going to put over here, and I'm going to give you some examples. I don't even like that guy because he doesn't like to do what I want it to do. This is what we call exponential notation or exponential form. This is the exponential form, and this is the logarithmic form. And I can tell you right now that as we progress with this chapter, your ability to go back and forth between these two forms is going to be very crucial. Okay? You have to be able to go back and forth between the two forms, even though you don't like to. So this y is the same thing as that y. And a couple of things that you will notice, the b here is the base. In this case, the base is 2. X is the exponent. But here's what's interesting. We talked about inverses before, and we know that the input of one function is the output of the other. Remember that? How they, like, you switch input and output for the functions? Yes? That's why when you try to find the inverse function, you switch x and y. It's why when you graph and you have x and y, you can invert the variables when you graph them. Remember all that? The input and the output switch. So, right now, if I look at this, the input is x and the output is y. But in this function, the input is y and the output is x. So they switch places as well. So it's consistent with that concept. So, an easy example. Because after this, we're going to have to get you to understand how logarithms work. I know, and so do you, that 2 to the third power is what? What's 2 times 2 times 2? 8.
Yeah.
So we want to start with some normal numbers instead of like a variable, just kind of use some normal numbers. This is exponential notation. The y value is the 8, the x value is the 3, and the base is 2. But we all know that 8 equals 2 to the third power. How could I write that as a log? It would be log base 2 of 8 equals 3. So the way it works is, this is 2 to the third equals 8. This is 2 to the third equals 8. It kind of makes a little circle. All right? So you want to try some?
What did the log
Yes.
mean?
That's what?
Oh, yeah. Never mind.
What does log mean?
Yeah, we'll find out.
It's the name of the function.
Oh.
You won't find out. I already told you. It's the inverse of the exponential. That's like asking, what does exponential mean?
Oh, okay.
It's, you know, it's raised to a power.
Got it.
The logarithm basically undoes the exponential. So what are you looking for when you see logarithm? It's really important that you pick it into this number. This is your base. Okay? So what you're looking for with the logarithm is, what exponent do I need to raise this number to, to get 8? So for example, I want to give you some other ones because you have to get used to this. What would the log base 10 of 100 be? And if you know the answer, don't say it right now. I'm going to kind of walk you through what you're supposed to be thinking. You look at this number, this is the base. So the question is, what exponent do I need to raise the 10 to get 100? In other words, 10 to what power is 100?
2.
So the answer is 2 in this case. Because 10 squared is 100. Yes? So what if I said then log base 5 of, I don't know, 125? The question is 5 to what power is 125? 5 times 5 times 5 times 5 times 5?
No.
I don't think that's too much.
5 times
3.
5 times 5.
So 3.
Yep. Yeah.
So 5 to the third power is 125. This is how you can get used to writing it in exponential form. This would be the equivalent to 5 to the third power is 125. This is the equivalent of 10 squared is 100. This is the exponential form. This is the logarithmic form. And again, I said earlier, your success as we progress, as we move further, is going to be your ability to go back and forth between those two forms. Yes?
Oh, you could just do it on the calculator too, right?
No.
Oh.
Good point though. Your calculator works in two bases, base E and base 10. Okay? So in fact, for example, we know, based on what I just told you, we know that the answer to this is 2 because 10 squared is 100, right? So because this is a base 10, the calculator will do that for you. So go ahead and try that. Go to your calculator and go log, the big fat LOG button, and put 100. And you get 2, right?
Yeah.
But put log 125. And you're going to get something not so... What'd you get?
2.09.
Where's log?
9.0013.
Are we not like?
But the answer's supposed to be 3. That's not even close to 3. It's 2.09.
Our calculator is not good enough.
Look at you. Shame on you. Why are you hating on your calculator?
My calculator.
No.
TI-84.
The problem is, that's what I just said. Your calculator is automatically working in base 10.
I mean, I don't have a log.
So as long as this number is a 10, yes you do. It's right here next to your 7. L-O-G. Yeah, okay. Everyone heard that now. Just laughing. Okay. Are we okay?
Yes.
Everyone has a log button, including Ethan? Okay. But I want to be very clear. Anytime you have a 10 here, then yes, you can use your calculator. It will do it for you. But it will not do base 5s or base 2s or anything other than base 10. But your calculator is limited. Okay? Now, I do want to know like why your calculator is giving you that answer. Like, why is it giving you this weird answer? Is this wrong? It's not wrong. Your calculator is giving you a base 10. It means that log base 10 of 125 is that. When you put log 125, the calculator is automatically in base 10. So it's telling you that 10 to that power is 125. So if you actually go and put 10 and raise it to the 2.096910013, I get 125. Do you see what I mean? So it's not that it's wrong, it's just that you're doing the wrong base, the different base. Okay, Nathan, did you understand that?
Yeah.
Because you asked that question, so I want to make sure that we're clear. Yes?
Yes.
Okay, so let's see if we can, I'm going to do an example here for you, and then I'm going to have some of you volunteerios come up here and do some others.
I want to be a TV screen camera.
This is our first technical example. It says write 25 equals 5 squared in logarithmic form. And I'm going to abbreviate in log form. Okay? So all I'm doing is I'm taking this little guy and I'm writing it in log form. So obviously, if it's gonna be in log form, I have to have the word log in it. Log, and then what goes right here, it's a little subscript, so it should be smaller. Don't make it like as big as the normal thing, okay? It's a subscript, and what goes here is the base. What is the base in that example? 5. So log base 5, okay? And then what does it equal?
25.
25. So 25 goes here. And what's the exponent? 2. So you can always check. I know that it seems kind of cheesy, but a lot of people like my little circular motion. 5 squared is 25. Is that true?
Yes.
If that's true, then we're in good shape. We did it right. Okay, so now I'm going to need, looks like 3 voluntarios
Oh, picking it.
for the do-it-yourselfers.
I'm about to do that.
And the directions are going to be the same. Right
This direction.
each, the directions, write each equation in log form. It says logarithmic, that word is just too long. It's just too long for anyone to have to spell out. Okay, especially when you're like in a hurry. I'm not really in a hurry, but you know what I mean. 729 equals 3 to the 6, there's 1. And then we've got 1/2 to the 3rd power equals 1/8. And I know that fraction scare you people, but it shouldn't. And then we have 10 to the 0 equals 1. Awesome. So I need 3 peeps. And I'm not even going to look out there. I'm just going to say, come up here. And if you're up here, then I guess you're what you're doing.
Oh wow, this is.
So scary.
Ow. Sick.
Got this. Was log and 3 is 0, 7, 6.
Awesome. And you can check that. You can say 3 to the 6th power is in fact 729. Awesome.
I'm on.
Your mom's not going to watch this video,
She
is she?
is.
Oh, does she watch the video with you?
You like
How
it?
cute.
No.
My mom sucks at it.
And now there's like 30 people laughing.
I like water. It's good for your H2O proteins. There you go. Sorry, chemistry. You should know that.
Awesome. 1/2 to the 3rd power means you would cube the top, cube the bottom, and you get 1/8. So B is correct. All right? Where's your base? Uh-huh. So you need to write the word log first.
I was playing with my computer better.
And a little subscript for the little base. Now what does it equal? Mm-hmm. So a big one. A big one. Not a subscript, yeah. Equals.
Wait, no.
Do we still have to write the do-it-yourselves in the notes?
Of course.
True, because 10 to the 0 power is 1. Anything to the 0 power is 1. Okay? So, good job. This one can get kind of tricky, but remember that anything to the 0 power is 1. So, yeah, 10 to the 0 power is 1. Alrighty? I'm just going to suggest that all of you, well, probably with the exception of Nathan over there, you really want to make sure that your bases are written smaller than the rest. So like, I don't know, like they look the same size. Just saying, well, this one's kind of bigger, but it's.
Wait, the base?
You want to make, when you write it, like you want to make it's got to be like way down there. And then 729, like
Wait, is
the
7?
3 and the 6 are on the same line. Like the base should be a little subscript, it's like it should be smaller.
Is the 729 and the 6 the same size?
Yes.
Oh.
Okay. And this guy should kind of be like log and then like a little subscript down here. You know how when you write a square root,
Yeah.
the little square is small or the cube root is small? That's how small it needs to be. And then 1/8, all big like. Okay, so those little subscripts need to be a little bit smaller, all right? Just gonna say that for you. All right, now we're going to do some more easy stuff,
Oh, you're right.
okay? And we're going to evaluate logarithms, okay? So, evaluate, this is example 2 now. we're going to evaluate, where am I here, log base 8 of 16. What that is telling me is that it's missing a piece. If you think about what the logarithmic form looks like, there's supposed to be an equal sign, and it's supposed to equal something. And in this case, we don't know what it equals. So we're kind of having to fill in the blank, all right? So it's not hard to do, though. We already did some earlier anyway. It's like a little question mark, and it's asking me 8 to what power is 16?
To the quarter.
8 to the quarter. Half. I got half, I got a quarter. Who's looking at the book? You're kind of, well, you're wrong. You're kind of, ding, 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 ding.
Oh,
It's gonna be a fraction.
I remember this from the homework. It was like 3 over 4.
How do you remember homework?
Let me try that.
Maybe it's a test.
Oh, it was
Four
thirds.
Yes. Yeah.
Yeah,
it
yeah,
was.
yeah.
Four thirds.
Yeah, 4
Okay. So 8 to the 4/3 power equals 16. Okay? 8 to the 4/3 power equals 16. In other words, if you remember your exponential functions, and you showed from the test, yes, okay, that's going to be 8 to the 1/3 power and then to the 4th. Yes or no? Because 1/3 times 4 is 4/3, correct? So 8 to the 1/3 power is the cubed root of 8, which is 2, because 2 times 2 times 2 is 8. So really what we're saying here is 2 to the 4th, which is 16, right? So it is true that 8 to the 4/3 power equals 16, so the answer for this guy is 4/3. So your answers can be fractions. I want to just, be clear about that. They're not always going to be easy peasy Japaneses, okay?
Would it be wrong if
So-
you were to add the decimal?
No decimals. No. We don't like any decimals. Not in this one. Okay? So now I'm going to need 3 more people. And we're going to have A is log base 64 of 1/32. And then we're going to do, I don't see anybody. Are you guys all scared? You know what's funny though, is that if you were at home, you have to do it alone. But you're here, and I can help you, so I don't know why you're scared.
Ethan, sit down.
I always tell my other classes that, the longer you wait to get up here, the harder it's going to get. So, yeah,
I was over again.
Well, this guy came up again. Is there anybody else?
Sure,
I'd rather new people come up.
Ethan, sit back down.
Justin's over there.
I don't even
Get
know how
over,
to do
Justin.
it.
We'll figure it out together.
There's it?
Yeah, we will.
Say, do you go back up?
I'll go up.
Can I bring my calculator?
Bella,
Or are you going to bring yours?
bring your calculator. Yours feel better?
Oh, okay. Is that a 9?
Yes.
Oh,
Sorry.
wait.
Did I do it the first time?
That was Kelly, by the way.
Isn't she
So you guys can just stand over here for a sec while he just does his, you kind of be out of the way. Not you, you're gonna go. Okay, so 64, and we've got 1/32. So any ideas? No? Are you sure? It's a fraction again.
164. I don't know. 132.
No, I think you want to do it too. Let's do this. Come over here and ask yourself, 2 to what power
One on my phone?
is 64, and 2 to what power is 32?
It doesn't.
Yeah, so just like, go like, let's say you put 2 to the 4th power, what do you get? 16. So 2 to the 5th power is 32, so put 2 to the 5th.
Yeah, I did do one of
It doesn't matter. You have to kind of be at an angle, otherwise it won't let you see. Yeah. Okay, so 32. And then what's 2 to the 6th power? 64. So 2 to the 6th power. Okay? So you want the answer to have a 32 in it, but it has to have a 64 base, okay? And it has to be negative. Why does it have to be negative? This is 32 to the negative 1 power. Ethan, let's pay attention, yes?
Yes.
Do you understand this?
Kind of.
When you have a fraction,
Oh, okay, yeah.
when you have a fraction, can you move the 32 to the top? Sure you can, but when you do that, you have to make it negative. So now it's 32 to the negative 1 power, right? And now you're going to put your 2 to the 5th, right? So now you're saying 2 to the 5th to the negative 1 power, because 2 to the 5th is 32, right? But now what's the problem? The problem is that you have a base of 64. So where does the 64 come into play? In other words, okay, so let me backtrack real quick. For all of you, let's say you have log base, I don't know, 10 of 1,000. Can you do this one? You know how like when you rewrite it, you have to rewrite it with this number. It has to be 10 to some power that equals 1,000. What would that power be? 3, right? Not a big deal, okay? So what I'm saying is, when you rewrite this, your answer has to start with the 64. Okay? So it has to start with the base. The base is 10. So this base is 64. What's 64? 2 to the 6th power. So you have to have 2 to the 6th power to some exponent, okay, is going to equal 1 over 32. You see what I'm saying?
Yeah.
Okay, so now how can I get the 2 to the 6th to be 2 to the 5th instead? You make it a fraction, right? So, you don't know? Okay, so let me just show you what I'm doing and I'll go backwards so that you can see. Does anybody else see that? Is it like that weird? I think the answer is 64 to the negative 5/6 power.
Okay, let's just see what you said.
Okay, but why?
To make it equal that.
Okay. Stevie, do you have an answer?
Why?
Why? Why is it
Saw
that?
the two numbers there, so I put them together.
These numbers?
Yeah.
Interesting. So we're going to go backwards. Can I break this down? No? Sure I can. I can go 64 to the negative 1/6 power and then raise it to the 5th. What is 64 to the negative 1/6 power? You have to answer one of the questions. It's kind of up there already.
32.
No? That's 2 to the 5th power.
Oh.
What's 64 to the 1/6 power?
Oh,
2. Okay? So then it's actually 1/2.
Yeah, that's what I got.
And that 1/2 to the 5th power is going to give you the 1 over 32. Okay? So you want to break this down into these numbers here. So see how I went 2 to 64? If I make that a negative 6, then it would flip over. It would be 1 over 64. Does that make sense?
Yeah.
So, and we need a fraction in there, so there you go. That one was kind of hard. Don't worry, you're cool. The answer was negative 5/6. Okay, and I gotta erase this so that, who's coming up here? I don't know who's behind me.
I would.
Callie.
That was for Ben.
Callie's coming up. What's for Ben?
Nothing.
There we go.
I didn't get that.
Actually, took the, I think I just had the eraser, that's why it's doing that, sorry. That'll work. Log.
Oh, I don't know.
That's
Wait, isn't it?
Awesome.
Nice, Kelly.
six,
Very good,
No,
very
you
good.